So, a circular economy is a new paradigm that's sort of taking the world by storm right now, and a lot of countries are focusing and regions are focusing on how they can develop strategies and policies around developing out a circular economy. Now, a linear economy is the economy that we are used to, the one we've had since the Industrial Revolution, where we take resources, we make products, we sell those products in markets, and then the end user or the consumer takes the product at the end of its life and discards it as a waste. Now, we all know, we've seen waste dump sites everywhere. It's not sustainable. And recycling is one aspect of a circular economy that alleviates some of that waste that's being produced. However, in a circular economy, you want to design waste out of your system. So in your production processes, from when you're using the resource, transforming it into products, even transporting it to the end user, in each one of those processes you want to get more efficient so that you minimize waste produced at each one of those stages. And that is where the circular economy has a great, it can make a great impact onto sustainable development in terms of keeping our resources in use as long as we can at the highest economic value we can assign or ascribe to it. So by doing that, you also lessen your requirement for new resources because the resources are being reused. So it allows, ultimately, it may allow for nature to regenerate itself, for biodiversity to regenerate itself. And so that is why it's being seen as one method by which we can start addressing climate change at the same time. Now, coming to an agricultural production perspective, in agriculture, you use a lot of water, firstly. Agriculture uses approximately, on average, 70% of freshwater resources around the world. And latest work done in South Africa shows that of the produce that is grown through agricultural processes, almost 40% is wasted, either on the farm or in the agro processing or in the transportation, or even just sitting on the shelf and going to waste. So that's quite a large number when you're using that amount of water. So water efficiency in agriculture is critical. As we know, especially in Africa, with climate change, Africa will be the hardest hit continent, on average 2 degrees warmer than whatever the average is around the world. That impact on agriculture and on water resources in particular is going to be a critical impact that has to be looked at very carefully in how we mitigate that. So mitigation of climate impacts on water resources is something a lot of people are casting their minds to understand better. And at the last COP28, water really rose up as one of those critical resources that will be majorly impacted due to climate change. So that's the one aspect, getting more efficient. And with IMI, you've got a large group that we have within the organization that looks at irrigation, especially for smallholder farmers, which in Africa are the majority of farmers. We don't have, very, 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 very few countries have big commercial farms. So there's that aspect. Then the other aspect is also on the use of chemical fertilizers. Why is that important? Because a lot of times farmers over-fertilize. So they use more fertilizer than the plant can actually take up, which means when there's rain or you've watered, the excess chemicals end up in your water streams. So you end up with excess nitrates and phosphates in your water streams, and you end up with these cyanobacterial blooms. When the water goes that bright green, and you can't drink it. Or you've got invasive plant species in your water courses like water hyacinths that then bloom and they take over the whole watercourse. So how do you limit that? You need to look at other processes by which you can provide the nutrients back to the plants. So you can till, so for instance, your waste products, your residue, you can till that back into the soil and let it degrade and thereby provide nutrients back in a very natural cycle. There are other methodologies that can be followed as well. Another alternative is if you have a crop, let's take sugarcane as an example. You don't use the entire plant to refine to sugar. The discard, the residues, in Mauritius they did this for quite some time, is you take that and you burn it and you produce energy that you feed back to your machinery, for an example. You can take it, you can make biodiesel out of it. It's not that efficient a process, but there's an emerging process that's known as biorefineries that have come to the fore as well. And biorefineries are like a petroleum type refinery, starting with woody biomass type material, so your discarded waste from your plants, and you can make chemicals out of that through a process using enzymes and bacteria, and in a controlled situation you can produce different chemicals with different uses. So you can start to find chemical industry based around biomass waste, as an example. So that talks to us more on the agricultural side. Then if I'm looking, if I were to look at Ethiopia or Kenya, in Kenya you've got these massive slums with a big sanitation problem. It's very hard to service the people that live there because a lot of the time the houses are too close together. So your municipal trucks can't really find their way in there. So servicing the pit latrines is very difficult. So in Nairobi they had a program. I'm not sure if it's still running, but where they had people that were employed that went in and emptied the pit latrines, and then that waste that they collected can be transformed into various other products. You can compost it, for an example. You can turn it into biochar, which can also go into soils. And it's a different example. These are both examples of a circular economy at work. When you're looking at water recovery, resource recovery from water, so wastewater contains a lot of nutrients, and you can recover that in various forms as well. So algae, if you have an algal pond and you can recover the nitrates and phosphates they feed the algae. The algae can be a source of multiple things, from beta carotene, which is a vitamin, to biodiesel made from the lipids or the fats contained within the algae. So it can have various other factors besides the fact that it's removing this nutrient overload that's in the water. But that's on a defined wastewater treatment works. So those are more concrete type examples of how a circular economy can function. There's also looking at the textile sector and how you reuse textiles. So clothing, for example, fashion being what it is, every season the fashion trend changes, so you're buying new clothing all the time. That talks to consumerism. And in order to go circular, you also have to tackle the consumer aspect. People need to realize they don't need so much new things all the time. So clothing, cell phones, sneakers, etc. need to be made to last longer. So you will probably end up paying a little bit more, but instead of your cell phone being out of date and useless after 2 years, it may work for 4 to 5 years. That's just an example. It's not real. It's something to think about, because a consumer can drive the behavior of a producer. So if the consumer wants products that last longer, jeans that don't tear after 1 year, you know, the producer is then forced to start listening to the consumer in a way, because they overproduce, because it's market driven, it's driven by us. We want more all the time, and we want more new things. I want to be owning more of whatever than the person next door, kind of thing. How do we change that mindset? And also, just a simple thing: put enough food on your plate that you know you can finish, so you're not discarding excess food and wasting it. Because just by doing that, another example that links it to energy, for example, is when you boil the kettle to make a cup of tea, and it's only yourself that needs a cup of tea, why do you fill the kettle and boil it? How much power are you using to boil that full kettle? Whereas if you filled it to 1.5 cups and then boiled only that water, it boils faster. And you've got enough water to make the 1 cup of tea for yourself. But it changes your power consumption. And power consumption gets linked again to water consumption, because water and power are interrelated as well. You need water to produce power, and you need power to move water to where people are. So there's a link that we're not always conscious of. So it's also small things like that. If 100,000 people do the same thing, it makes a big difference. But it starts with one. So how do we get people to understand that?